Good afternoon. Welcome. My name is Ryan Nix. I'm a partner solutions architect with Amazon Web Services, and thank you for joining me in a bit of a hybrid discussion. So, jumping into an interesting predicament. The customers I work with, many of them are large-scale enterprise entities, legacy tech debt, with a desire of migrating into the cloud. Some of them that is mandated. They've got an instruction from further up in the organization that there's no longer going to be investment into their own data centers, their own infrastructure, and some of the development teams are specifically told, you're moving to the cloud, make it happen. So what we see in these customers is a situation where a new problem set evolves. Some of these customers are moving into the cloud. Some application teams are able to do this very, very quickly. There is an innate skill set. They're building application stacks that make sense in the cloud, and they have the desire to, like, let's go. Other teams are sitting with a legacy debt footprint, the proverbial spaghetti bowl where you can't pick up that application workload and move it overnight. And they have a desire to sort of stay in an on-premise context for a little bit longer. And this results in an organization having part of the business on the cloud, part of the business on-premise or in another context, and they end up in a hybrid situation. So what this results in is an interesting set of tenets, or three distinct things that I'm hearing everybody wanting, and that is, I want my development team to have a unified experience. I want my developers to have a single place to go, a single process to go through when developing their software and deploying that software onto its target location. What is happening in some cases is I have a developer who's writing code, and when it gets to pushing that code to where it is meant to run, they have one way of deploying that solution on-premise, and then they have to hat swap or context switch to take that same application workload and deploy it into a cloud environment. This context switching, this interface switching is wasteful. I'm seeing many development teams sort of resist it because it implies I have to learn a new way of doing things, and that slows down the business. The next one is a little bit obvious, and that is a requirement for portability. I don't want my development teams and my operations teams to go through a management cycle of two completely different application work sets. I don't want to build an application that is meant for one environment, such as on-premise, and then have to build a slightly different version of the same application to run in a cloud context. Ideally, I would like one application, the same code base, and that must be portable, that I can pick it up and move it around and place it wherever I want. To extend that particular problem, my customers are saying, I want my developers to be able to develop wherever they develop, whether that is on their personal notebook or whether that's on a dedicated development system, and I want that application code to be portable enough that it can go from something like a notebook on an aircraft while in transit to a development platform, to a UAT platform, to on-premise, to wherever I desire that workload to run in the most portable fashion. And the next one is probably the most frequently asked, and it's being driven by many businesses in the startup sort of field, and that is agility. The desire to have feedback coming from a customer and the business being able to respond to that feedback in as close to real time as possible. And we've got customers and partners who are getting this feedback from their customers, their development teams iterating on that request, and in some cases getting that new application version, that new feature out into a production market in days or weeks, where if I look at the traditional enterprise, that is not the same kind of agility. It's a much slower pace. So I've got many enterprise customers giving us feedback saying, we desire that degree of agility. We need to evolve our business and get our applications into a production context where they are benefiting our customers faster. So anything that can give us some degree of agility is desirable. Okay, so let's unpack these three elements. So one part of the solution that addresses the portability aspect of a hybrid context is, for most people, somewhat obvious, and that is containers. The container platform gives us the portability. It gives us that ability to take an application and put it into something where it is self-contained, where the code, the assemblies, the dependencies of that application, everything is housed in a neat little unit, and I can move it around with ease. So if I go back a few years, what that looked like was a developer having Docker installed onto their development notebook, and they would be building their applications within that container platform, and that container itself being able to be picked up and passed along to an operations team, and that operations team could deploy it to a test UAT or production system, and there was consistency of deployment. That portability was very much desirable, and it's not changing. If you look at most of the discussions that we're having around us, many of them focus on containers or containers being some part of the journey. Looking at the flow, what we saw traditionally was a development team writing code, building out the container definitions, putting them into a source code repository, whether that is Amazon's code commit or whether that was a GitHub, it's irrelevant. Place to store the code goes in there, some sort of pipeline automation, detecting that code change, going through a container build process so that I end up with a container image, and then that container image being used to deploy my application workload to where it is desired. The obvious ones are a traditional on-premise data center or a cloud, but we're seeing a greater diversity of these targets manifest. I've got customers coming to me in the shipping and travel industry where their version of an on-premise data center is actually a cruise vessel, and that cruise vessel is now treated as a data center, and I need to synchronize my application workloads to those target locations, and I can't do that while those vessels are out on the ocean. When they come into dock, the software then gets deployed to that data center, and then that data center goes on a cruise out to sea again. If we look at some of the smaller form factors, we're seeing IoT devices with software on them. How do we deploy and keep that software in synchronization throughout a fleet of devices that exist out there? So that portability aspect is becoming more and more important to us. Right. That being said, the container platform has been so popular that if we look at the statistics from Docker Hub over 2017, we noted in the region of 900,000 container-based images being stored on Docker Hub. Of those, we saw in the region of 12 billion image pools. So clearly, there is a huge desire for containers. Many people have said containerization is part of the strategy my business needs to pursue. To contrast that, an interesting little statistic, 35% of those container workloads end up in a production context. 12 billion downloads of the container image, only 35% in production. So clearly something is at play here, and it's resulting in a lack of success in actually going into production. So of those 12 billion downloads, a large portion of those are sitting in a POC state. Some of them are sitting in the developer context where developers are using those things, but they are not readily going into production. Why is that? Very simply put, containers solve part of the problem, and that problem, when you move into a production and scale context, becomes interesting and difficult. So unpacking that further, we've identified we need more than simply a container runtime. We need to address a rather interesting collection of challenges, as we move further up the solution stack. Scheduling. How do I scale in the environment? So if I'm running in a production context, how do I scale my environment not only up, but how do I scale it horizontally? Running a container on a single development notebook is one thing. Running that same container application in a production context, I now have got containers spanning multiple underlying host systems. I have got those spanning multiple racks. In some cases, I have them spanning multiple data centers. How do I manage the deployment of those systems? How do I manage the networking of those containers to other layers within the application stack? How do I manage the interaction of those containers to other containers within the same layer? How do I monitor those, not just from a performance perspective or a health and availability perspective? How do I audit those from a compliance or a security standpoint? And this is incredibly important to the medical fraternity, the financial services industry, where there is regulatory compliance. So what we see is with container workloads, the developer turning around and saying, I want a container platform, and the security team saying, well, great, how do we meet the compliance monitoring footprint of those containers? Logging. Again, coming into us from an auditing and a compliance standpoint. What am I logging? Where am I logging it? How do I go about tracking what is going on within my environment? Long and short of it, as you can see, container runtimes are not enough. There are multiple layers that we need to address before we can take this into a production context at scale. So some of you might have already identified a potential fix to this, a potential solution to some of these, and that is a orchestration layer. So if we have a look at the likes of containers combined with orchestration, we end up with possibly Kubernetes as a orchestration footprint to manage most of this. And that allows me to introduce you to a customer of ours, Remind. They are a company that assists educational institutions with parent-student notification platforms. And what Remind did was they built their entire application stack, taking things like Amazon's Elastic Container Services. They used things like AWS Code, Commit Code, Pipeline, and they took all of these services and they linked them together to build out a pipeline DevOps process that allowed them container portability, but with an orchestration component as well. One or two of the functions they were looking for did not exist, and they had a competent development team that built out those missing bits and bobs to get them to the point that they were incredibly successful in servicing their customer base. Their response time increased, their scalability, their availability increased as well. So that combination of those DevOps platforms running on top of AWS. That being said, if I look at the enterprise customers that I'm working with, financial institutions, airline industries, public sector entities, defense force contractors, I'm getting a consistent message from those customers. They're like, great. There are tools, there are third-party solutions, there are open source solutions, and we can take those solutions and we can aggregate them together. But we don't want to. So these are what I'm getting from a more enterprise-focused customer. Unified experience. I want to be able to manage a hybrid context, both on-premise as well as cloud, as well as any other platform that I'm working with. And I want my development, my operations teams to go through a single pane of glass, single interface. I don't want context switching. I don't want that wasteful hat-swapping exercise. The next thing is we want a turnkey solution. We know that we can take other things and stitch them together, and we know that we can develop these solutions in-house. We don't want to. We would desire an out-of-the-box turnkey solution that gives us all of that in one installation with a configuration. That way, I can take my developers, I can take my other teams and focus them on building what is important to us, which is the applications that my customer is going to consume, not building out things in-house in the business. The next thing is many businesses are not fully aware of the best practices, the security recommendations which apply to their industry. They know parts of those things, but what they're really looking for is a guided recommendation. How do I approach container security? How do I make sure that my processes are secure? So one of these asks is, if I'm going to utilize a platform to do this, that platform must inherently cater for that guardrail environment, that protective recommendation that my teams can then slot into. And then going through that process, I can learn the lessons and I can evolve that within my business. And you can see that these three things are not necessarily easy. So if we have a look at application platforms are providing these three factors. To look at one of them, let's take a look at Red Hat OpenShift, for example. It is a self-service platform, caters for multiple languages, so my development teams can code in the language that is relevant to them and deploy those applications onto the solution. I don't need to learn a new language. Automation platform, so there is pipelining, there is build processes built into it. It caters for the DevOps solutions that I so desire. A collaboration platform, not just DevOps collaboration where I have developers talking to what were traditionally sysadmins in an operation context, but beyond that, a collaboration platform where I can bring my security teams into that same perspective. And I now have security teams communicating with developers, and I can get faster feedback to the development teams, which means I can address concerns faster, and I can be more agile in terms of fixing those and getting them into the market. Further up the business food chain, I have my C-level and my business owners having an insight into what those applications are doing. So I have a much more encompassing collaboration platform, should I desire it. Multi-tenant solutions. We are seeing more and more systems requiring a multi-tenant context where I need to cater for various customers, and in some cases, those customers are dictating to the multi-tenant provider where that workload should run. So I do have customers that have their downline customers saying, I want this workload to run on AWS. I want this workload to run on my on-premise data center. And I need to cater for both sides of the fence. So a multi-tenant platform in terms of delivery immediately triggers a hybrid context. More importantly, how do I separate those from a security platform perspective? How do I track multiple customers, and how do I charge back or bill those customers? Instead of building these things out themselves, these application platforms cater for that ring fencing of those customers, the deployment facets, as well as the means to sort of track and bill those entities independently of each other. Obviously, we want this to run at scale, so these solutions need to be able to scale not only up but out and cater for what happens when that scaling occurs, what happens when failure occurs, how do we detect those failures, how do we respond to them, and how do we automatically address those. And this is something that we've seen in cloud environments for some time, and it's become almost the norm within business requirements. And then one other thing is the security, making sure that that guardrail implementation is being brought through into the application platform. This is Red Hat OpenShift that we're looking at over here, but if you look at other application platforms in the space, you look at Pivotal Cloud Foundry, for example, you look at the cloud application platform by SUSE, we're seeing very much the same building blocks manifest. A container runtime for portability, we're seeing orchestration being built in, we're seeing monitoring not just of the container platform, but monitoring from a security standpoint, aggregated logging, dashboards for visibility. We're seeing a lot of those upper-level business functions being brought into the application platform, and we're ticking that turnkey solution. I want everything out of a box requirement that the enterprise business is asking for. Cathay Pacific. Through using AWS and an application platform, we're able to take a relatively small development team and build a completely new application platform to interact with their customers and 6 months. That's 6 months from the drawing board, going through development, test, UAT, everything into mass production. A significant win for them in terms of getting things into a market where historically things took quite a bit of time to get out there. And in so doing, they've created a bit of a knee-jerk in the industry. Other airlines are now turning around going, we can't compete with that degree of agility. What are we doing differently? How do we close that gap? We're seeing the same thing happen within the financial industry. Whether it is a banking application or a stock trading system, the minute a financial institution is able to take their product and get it out the door into production faster, everybody around them has that shock and horror moment. We're not able to keep up with a competitor. We want the same degree of agility. And we're seeing this knock-on force within multiple platforms. I'm not only talking about the benefits of these application platforms themselves. When you take these application platforms and you run them on top of AWS, you now get a very powerful aggregated effect. That is the elasticity of AWS, the scalability, and the inherent availability footprint that AWS has gets combined with that of the application platform in a hybrid context. If we look at this from a security standpoint exclusively, you see the security footprint of AWS, our compliance benefits, our compliance certifications, combined with the guardrail recommendations of those applications. And suddenly you see why many financial institutions and medical institutions, sectors within a compliance space, opting to run their application workloads in an application platform on top of AWS. But this creates a new challenge. I end up with a customer coming to me and saying, we're a traditional application platform consumer. We've been using it for years on premise. When I move my workloads to AWS, do my development teams now need to go through a semantics learning discussion? Do I need to wrap my head around a plethora of new products before I can start modernizing my application? How do I go about migrating my application from on-premise onto the cloud? So there are some of those concerns. So first step, customer comes up and he says, I want to get the application platform I'm familiar with on-premise running on AWS, and I want it up and running right now as fast as possible. The longer I take to get it up and running, the longer it takes for me to get organizational change buy-in, the longer it takes me to convince teams to actually consume this platform, and there's a bit of financial waste here. I have something running, it's costing me money, nobody's using it. So what we did is we worked with various application vendors and we built out a collection of Amazon Quickstart solutions. These are infrastructure as code templates where a customer can take the Quickstart for OpenShift or the Quickstart for Pivotal Cloud Foundry, and by simply filling in a couple of parameter inputs, they can have a reference architecture, scalable, production-ready application platform running on AWS within hours. The OpenShift Quickstart will launch from end to end in just over 2 hours. If I were to handcraft this deployment using EC2 and an engineering team itself, more commonly that is hours, days. So straight away, this is that first step of agility to help the customer get up and running as quickly as possible. Get the base foundation there so that developers can start interacting with the system. Likewise, we are seeing more and more of these quick starts being brought into the market. So we're seeing Pivotal Cloud Foundry, we're seeing Red Hat's OpenShift, and there are more to come as we proceed. Right. The application platform being up and running is not enough. So what we wanted to do was close that gap between what I had in terms of managing an on-premise workload and managing the cloud. How do I take somebody who's writing an application that was running on-premise and not only getting it into the cloud, but modernizing it within a cloud context? So we looked at something called the Open Service Broker API. This was a an API written so that you could build service brokers to interact platforms with other platforms. And what we did is we took the Open Service Broker API and we created something called the AWS Service Broker. What it essentially does is it has an application platform on the left, whether that is OpenShift or Pivotal Cloud Foundry, or whether it is a SUSE cloud application platform. And we took those application platform native controls and we integrated the service broker with them. And what we now have is the ability for a developer, instead of that developer to develop their application in the application platform, then step out of that application platform and go to something like the AWS console and stand up a AWS service, build it out, then take all of the pieces of information that would be required to consume that application, an endpoint, a username, a password, whatever, then hat swap again, go back to their application and stitch those together. What we've now created is a single pane of glass. A developer can be working in something like Red Hat OpenShift, and from within the application platform, build their application, and from within that same platform, provision an AWS service within an AWS account, and then once it's built out, expose the connection information back to their application without leaving their developer platform. So we cut out that waste. Right, so looking at this diagram very quickly, what you can see is, irrespective of the platform itself, it could be something like native Kubernetes. We create the application, we create the AWS service, that create or push call gets sent to the broker, broker interprets that and collects parameter inputs that the developer would have provided, sends those to the back through AWS CloudFormation. These are infrastructure as code templates that we've built out, and it kicks off CloudFormation in the background, builds out those resources. So whether this is a database that is going to be consumed by the application, or a queuing mechanism, or a notification service, it's built in the background in the AWS account. Once that resource becomes available, we take the outputs of that application configuration component, pass it back to the service broker. The service broker itself then uses that application platform's native security storage mechanism. So in Red Hat OpenShift, we take advantage of the secrets that are stored inside the platform, and we store the endpoint, the connection details such as username and password, safely as a secret in the environment. Likewise, if this is Kubernetes, we're storing those as secrets. If this is something like Pivotal Cloud Foundry, we store those secrets inside VCAP services. Long and short of it, we no longer have a human being sitting with a endpoint address, a username, and a password that they need to place into an application environment variable set. We store it within the application platform, and through a binding process, we expose that to the application. So we end up with a heightened security platform there. Right. There are a couple of questions I'll come back to in the demo later where I'll actually show you this process in practice and give you a sense of what it is like for a developer to go through this. We announced the service broker in November last year at the previous reInvent. Since then, we have 18 services that have been deployed via the broker. A cross-section of databases, relational, NoSQL, messaging components, queuing components, caching layers. We've been taking feedback from various customers and looking at what are the building blocks that are part of those applications. And what we now have is the ability for a customer to take an on-premise workload, move it to AWS through a portability factor provided by containers, and then start a rapid modernization of that platform. So taking the database container they had on-premise, and when they get to AWS, picking that up, lifting and shifting it across, and once it's running on AWS, using the service broker through the same development process, building out something like a relational database service, RDS, and then cutting over the application to use RDS instead. This allows for the developer having very minimal experience about AWS or about the services before they can take advantage of these platforms and actually modernize the application. Right. Very quickly looking at this journey of a customer from on-premise into a hybrid context and out of it into a cloud-native context. So we see the application platform providing a unified experience for managing applications on-premise as well as on the cloud. And what we see on day one is a lift and shift sort of motion. The containers that I had running on-premise simply being ported into that application platform, and now I have the exact same container platform running on-premise as well as on the cloud. Very little change to the application. It's what I had there. Historically, what would then happen is customers would go through a process of learning AWS services, exposing themselves to semantics differences, wrapping their head around, how does this new environment relate to what I'm familiar with on-premise? And that might take longer in some companies than others. So we've tried to simplify that as much as possible. But on day one, what we start to see is very simply EC2 being used as a replacement for my on-premise virtualization platform. Most customers I work with are tired of running their own database platforms. They don't want to manage the database itself. They want something that is highly resilient. They want something that can scale. They want to focus on the database itself, but they're not interested in the infrastructure. So very rapidly, there is this adoption of something like RDS, Relational Database Service. I want to run a managed database on AWS. I want my developers to focus on the database content and the application, and I don't want to focus so much about managing the database itself. So this next step makes sense to me and many of the customers I work with. As we move further along, we start to see a similar sort of thing. How do I monitor the environment? How do I keep track of consumption? How do I keep track of expenditure? How do I start monitoring the environment from a auditing and security platform? So very rapidly, we start seeing things like AWS CloudWatch coming into the picture, AWS CloudTrail, and for many of you in the room, you're already seeing these systems in play in your architectures. We then see the development and operations teams starting to go through a secondary phase of modernization. How do I take the application that was running on-premise using one queuing system, and when I move it across to AWS, how do I cycle that out for a different queuing or a different messaging platform? So we start to see things like AWS SNS, AWS SQS, queuing and messaging notification services coming into the picture. Caching layers. We start seeing Elasticache coming in and being placed in front of things like my relational database services platform or in front of data warehouse systems like Redshift. What was interesting to me, however, was the very early adoption of AI/ML platforms, things like SageMaker and the ability to train and do data science modeling, coming in as a very early adoption phase. Whether this was in the medical industry or the banking industry, we have this growing desire of businesses to be able to churn through data, analyze it, and come out with business decisions infinitely faster than what we had in the past. So SageMaker coming into the picture in terms of data modeling and data sciences over there. Right. Suddenly we get to a point in the journey where security starts becoming a bigger concern. And some of the AWS services coming into the picture, things like the web application firewall surrounding my application stack, but as well my application platform solution. I want to get insight into what is the security posture of the applications I'm building. So am I exposing myself to vulnerabilities? What are my developers doing, and is there a layer of risk there? So we're seeing things like the AWS Inspector coming into the picture and targeting vulnerabilities that may or may not exist within my applications, and how do I go about addressing those? We're seeing AWS Config in terms of tracking desired state within my networking configurations and within my application stacks themselves. So as we move to the left, and we have that development team becoming more and more enabled and more agile, there is a desire for tracking and making sure that as we're doing that, are we introducing risks? Are they adhering to corporate practices and things? And you're seeing those security applications coming into the picture. Notice at this point, we start seeing the customer becoming very well entrenched with AWS. The services are now familiar. So we start seeing more native services in terms of deployment and orchestration coming in. We start seeing the adoption of Elastic Kubernetes service. We start seeing the adoption of Elastic Container Services. So my container runtime, my orchestration now shifts away from the application platform as we move away from on-premise. And as the on-premise environment becomes less and less relevant, so if this is a migration journey, we see the migration may take 3 to 5 years, but at the end of that 5-year journey, the customer has completely migrated all of their application workloads onto the cloud, and they can now move away from the application platform into something that is completely natively AWS. That being said, the biggest concern I'm getting from customers is I want to start this journey as soon as possible. I want to take that development team or that application workload that can start this journey rapidly, and I want to enable them. I want them to move on day one. But at the same time, I want to cater for those teams that can't move, and that application platform provides that middle ground to cater for both. But as we go through a 3 or a 5-year journey, we very much see all of my development teams, all of my application workloads being able to move. And once that journey is complete, we end up in a native context. Right, let me drag you across to a little bit of a demo standpoint. And what I'm going to do is run through a couple of things here. What I've built is a OpenShift cluster running on top of Amazon's EC2 instances. I have installed and configured the AWS Service Broker, and I've pre-staged a RDS database environment. So what I'm going to do is give you 2 examples of an application workload. The first is a development team who is able to build a cloud-native application. It's a re-architecture of the application. So they've taken what was running on-premise, refactored it, and the container is designed specifically for use on AWS. And what we're looking at over here is the service catalog within OpenShift, graphical representation, and you can see the service broker representing those AWS services within OpenShift. So just to contrast that, my developer does not have to step outside of this into a stereotypical AWS console. I will switch between the two just to give you a bit of context to what's happening in the background. But for example, let's go and create a quick project over here. Let's go call that something like a SQS demo, for example. These projects can be used not only in terms of ring-fencing costs and seeing where my expenditure is going, but also as control and configuration points. I can say a development or an operations team has certain permissions within the context of these namespaces or these projects. So already you can see the application platform providing a management layer of benefit. I'm going to quickly come down here to where is my SQS. So here is AWS SQS. Punch next. Already I've got parameter inputs. Am I launching something like a standard queue or a first in, first out queue? Let's go deploy a standard one. And parameter selection. Obviously, these parameter inputs are going to be provided from here through the broker into AWS CloudFormation in the background. And what we've done is, within these templates and configurations, we've provided the inputs already, and we are providing recommendations. You know, what are common sense inputs for minimums, maximums, those sort of entities. What we're aiming for is the developer having to provide as little input as possible to get the service up and running. We want them to be able to get it up and consume it and focus on the application. Obviously, they can override the settings through parameter inputs, and they can go a step further. They can even go as far as changing out the templates themselves. All right, and let's punch next there. I'm not going to bind this application at this stage. And what I have in the background is, if I go into that project, you can see over here, there is my Amazon SQS queue being provisioned through Red Hat OpenShift. It is being provisioned asynchronously, out of band. So what I'm waiting for is AWS CloudFormation in the background to build this out and signal that that resource is created complete. So I'm waiting for that information over here. If we jump into the AWS console and we have a look at what's happening in the background, there you can see the CloudFormation stack. actually coming up online, I'm not really interested in the granularities of that build-out process. What's going to happen is it's going to build out the SQS queue. It will provide all of the connection information through outputs, pass them back to the service broker. In the meantime, what I'm going to do is I am going to deploy a container image. I'm going to pull something out of a Docker hub. And deploy the application. The OpenShift platform actually caters for where does that container get placed on the underlying host infrastructure. It caters for the health checking. It caters for the routing or routing to that application. Let's quickly go and create a route through to that platform. And if I open that up as an additional tab, we get the application. This is not a shock and awe application. This is by no means high-level, production-ready enterprise. All I'm doing here is a very simple API call to SQS and seeing if I can put something in and out of the queue. And what I'm getting back is a delightful missing required parameter. It's the perfect error. My application's not working. Why that is because my application right now does not know how to consume this SQS resource I've built out through the AWS Service Broker. So what I'm going to do is create a binding, and that will take all of the information provided from CloudFormation to the broker back to the application platform, connection, anything needed to consume that service. We store it safely as a secret. And from within the environment, I can take that and I can add it to an application, and I'm going to link it to my SQS sample app that my developer deployed. That's happy. And now if I go back to the platform, you can see that application being rolled out with the change. And if I come back here, demo gods are in my favor. You can see a API result. Boring, okay? This is not representative of what most of us have. Most of us do not have a simple application that queries an API to a backend service. Most of us have an application with a database on-premise. There is some interaction with that database. So what we're doing is we are lifting and shifting most likely a front end, a mid-tier, and a back end into the environment, and then we need to go through a modernization phase. So in that context, what I've done is I've taken two very, very simple Docker container images, one for a front-end WordPress and one for a containerized MariaDB. I have loaded those into a simple container registry running on the CC2 instance. That could be any container registry. That could be Docker Hub itself. It could be something that is stored inside the company. From an OpenShift perspective, what we're going to do is we're going to create a YAML-based template file that specifies where are those container images housed, what are the components of those container images, and I'm going to import them into OpenShift. Once that has been imported into OpenShift, I can then take that container that was running on-premise or in my different environment, and I can consume it within the application platform. So let's get that up and running. Let's get my first lift and shift migration component running. To do this, I'm going to switch to just a console context, and I seem to have been logged out. So let's quickly punch in there. Just make this slightly larger. What I have over here is a pre-staged template, and within this template, this is required for OpenShift to bring those Docker images, those containers into the platform. As you can see here, I'm creating a deployment configuration. This is going to cater for both of those container images. It's going to deploy the front-end WordPress as well as the back-end database. It has the environment variables for WordPress to consume the database. So my database endpoint, my username, my password, the ports required for these application stacks to run. It also contains the image. Where am I getting this from in terms of my image repository? As you can see, this is a simple local repo over here. Right, from a OpenShift perspective, I'm going to do a OC. Wait, before we do that, let's just check that we are in fact logged in. Okay, I am logged in. I am going to consume a pre-staged project because that is where I have a database already, and it will facilitate a cut over at a later stage. Let's go and do a and seems we already have one called that, so let me do a replacement of it instead. And all that's going to do is it's going to take that template describing my 2 container images and load it into Red Hat OpenShift. Once it's over there, I can actually go and do a deployment of a new application using that template. And I believe I called it WordPress. Okay, and what it's doing is it's taking that template that describes my container images and deploying that within OpenShift. If we kick across to a graphical environment, there you can see the container workloads for my WordPress talking to MariaDB. Now, bearing in mind, what we have here is a typical on-premise situation. We're not changing the application in any way. This is the database as it was running on-premise. This is the front end as it was running on-premise. We're bringing that database container onto AWS, and it's running in the cloud. But it's not a database that is comparable to RDS. You're not going to get that managed platform. You're not getting something that is automatically going to heal itself. You're not getting the automatic resilience and high availability that you're getting from something like the relational database service. So what we want to do is we want to build out a database, RDS, and then cut the application over to that. So let's quickly go and show you what that would look like. Let's go create a new project, call it production. And let's go take RDS for MariaDB. Coming back to making the developer's life as simple as possible, if this is production, I'm making a couple of assumptions here. It's going to be highly available. It's going to require a degree of security, so encryption should be on. Encryption in transit, encryption at rest. So I want to take advantage of those RDS features. I want a recovery platform. So what is my backup process going to look like? Am I doing backups? Are they automated? When is that backup schedule kicking off? If I kick it over to a development context, some of those pictures might change. I might not want backup and recovery. I may or may not want encryption. I might be able to survive with a single availability zone, less resilient application. So the templates for production and development are slightly different. But again, when we go into those, my team has the ability to change what those parameter overrides are. You as a customer can take it even further. You could say like, great, this is a really good production perspective of an RDS instance, but it doesn't meet the use cases of my business. In which case, you could jump over to GitHub, go to this Service Broker project itself, and you'll actually find the infrastructure as code templates that we've built out. And there's nothing stopping your teams from taking those CloudFormation templates, modifying them to your specific business needs, and running something that is absolutely relevant to you. So various degrees of customization over there. Coming back here, let's just quickly go to production. I'm going to define where connections are allowed from. Let's make these within the VPC itself. So you can define the access CIDR. The port for this has been modified from 3306 to 103306, but again, you can adapt that to whatever you desire. Simplifying the amount of storage to the performance of that storage. This is something that some customers have to wrap their head around on day one. As I want more performance, I need to provide a greater amount of storage to achieve that, especially in an IOPS context. The EC2 instance types. Coming a little bit further down to the backup side of things, yes, I want my backups. Here are the schedules, and we've pre-populated times for those schedules, so you can simply fill them in as a drop-down. What day does that maintenance take place on? Is this publicly available? And we would need to provide a VPC ID. And through a couple of very simple parameter inputs, I have a developer working through an application platform, not stepping outside of their comfort zone, and building out an RDS instance on AWS. Again, let me quickly take you to the back end there. You can see that database busy provisioning. That is a multi-AZ database, so it will take in the region of 15 odd minutes, maybe 20 minutes to be up and running to consume it. I don't want to wait 20 minutes, so what I'm going to do is cut back to a pre-staged environment where I've already built out the RDS instance using the service broker. And what I'm going to do is I'm going to come into my WordPress front-end application here, and I'm going to come to the environment configuration. So you can see the original environment variables where it's told how to connect and consume the container-based database. What I'm simply going to do here is update the configuration map. So I need a couple of things here. I'm going to add in a database name again. I'm going to add in a database user. That would have been spectacular. Let's make that DB user. Pass, and because I am changing to my RDS platform, I need to provide some information around the endpoint that database is going to use and what the port is. This is Maria DB. Port, and I've just realized I've done myself a little bit of a disservice, but we'll see if I can reverse myself out of the problem I've created. Quickly going to my pre-staged database, I'm going to create a binding. Again, that's going to load all of those connection pieces into the secrets within OpenShift. If I expand that, go to those secrets, I'm going to add them to my WordPress application. So my WordPress application will now be able to consume those secrets. What might happen here is I might need to redeploy this. So let's quickly go and select the drop-down over there, and it is the case. I'm going to have to redo that. Let's quickly go back to my application right now is not seeing those secrets because I started editing this before. They were there. Let's go to... Notice the versioning. This is a second deployment. It picked up those environment variables being passed to it. Okay, let's try that again. So there's the service host. Let's go add in the service port. And if I select from the drop-down here, there you can see a credential set being provided from my database platform, and over here there is my endpoint address, and there is my port number, and let's just bring across the actual credential information. So my database name, DB name, Obviously, I want to remove the previous configurations. Let's go save that. And then finally, notice deploy is grayed out. My deployment should already be taking place. It's going to pre-stage. There you can see version 3 coming across. And it's taken those configurations in, and my WordPress environment is now talking to my RDS instance instead of the MariaDB in the background. Somebody in the room is now kicking and screaming and going, that's not good enough. What about the data that was on my original database that's now not in the new database? So in most of these cases, what we'd do is we'd take something like the data migration service that AWS provides and migrate the data in the original database through to RDS before cutting over. To date, I think we've migrated in the region of around 90,000 databases using DMS in that capacity. The takeaway from this, not only do we have an application platform that allows me to control my applications on-premise as well as on AWS, we have a way of modernizing those applications in a faster means. My developers can touch their application environments and manage the AWS services directly through the application platforms. They don't need to switch contexts. Very much an enabling force. So a couple of security concerns I've had in the past. I've had people come to me and say, are we providing developers with an unrestrained full access to the AWS account? No. The security configuration is within the service broker, within the application platform. So the application platforms are being able to consume roles within AWS and do things within the account. The developers are controlled, or the human beings are controlled through the traditional role-based access control platforms provided from the application platform in itself. I hope that gives you an interesting perspective on how application platforms are changing the landscape for customers in a hybrid context, allowing people to move their application workloads and at the same time continue to service applications that are not able to move while in that hybrid context, but also give you a glimpse of what a migration would look like as well as what an application modernization platform may entail. And I invite you to grab me in the hall and pose any further questions you may have. Thank you very much for joining us.